Hi, everyone, and welcome to the Daily Tech Show. I'm your host, John Myer. And before we get started, what is this show all about? I'd like to say it's for us geeks, but I think everybody's going to enjoy it. We're going to bring you some awesome discussions around public cloud with public cloud leaders and developers, plus some quick tech news around AWS. Now, I know I said I'd sprinkle some of those other public clouds, but I haven't found anything interesting yet. So, moving on. Are you interested in learning what Kubernetes is? Or maybe you heard of K8s and are wondering how K8s equals Kubernetes, because I know I am. Then you're going to want to stick around and listen to John Slaughter. Yes, that's his awesome last name. Plus, we'll be talking about Spot Ocean, and that's right, Pokemon Go. All right. So, before we begin, if you like what you see, don't forget to hit that like, subscribe, comment, and also at the end of this, John and I will be playing the Google T-Rex game for bragging rights. Right now, I'm undefeated. So is John. So this is going to be interesting. Real quick, some quick tech news before we begin. I'm not sure if this is actually tech news worthy, but Amazon has updated their leadership principles from 14 to 16, right before Jeff Bezos departs as CEO of Amazon and Andy Jassy takes over. If you haven't heard of them before, these principles describe how Amazon does business, how leaders lead, and how they keep customers at the center of their decisions. Personally, I like their leadership principles, and it's a good way to have a set of guidelines or standards. The two new ones are strive to be Earth's best employer and success and scale, bringing broad responsibility. Since recently leaving AWS, I find them fitting due to an isolated micromanagement issue. Glad they're taking a step in the right direction. All right, now some useless news. Did you know there's a petition urging Jeff Bezos to buy the Leonardo da Vinci's Mona Lisa and eat it? Oh, yeah, and it's got hundreds of signatures. I'm going to stop right there because what the? All right. So don't forget, if you like what you see, hit that like, subscribe, comment. As always, we're going to share some cool things, and you want to wait to the end and watch me beat John at the T-Rex game. Let me introduce a personal friend and colleague of mine, John Slaughter, who is a customer success engineer at Spot. John, welcome to the show.
Super happy to be here. Thank you.
So, John, before we jump into our topic today, how about we give the audience a little bit of information about you?
Sure, absolutely. As mentioned, my name is John Slaughter. It is my real last name. Born with it and love it. I'm a customer success engineer at Spot by NetApp. Fairly recently joined the team, but it's very strong and going great. I'm located in the DC area, working from home, as you are as well. And I love technology, very passionate about it, and super happy to be here talking about more technical features we have.
So, John, we're talking about containers, orchestration, and the infamous Kubernetes today. Also, Spot by NetApp's awesome product called Ocean, and how it can help with your Kubernetes environment. What are containers? What is container orchestration? Kubernetes, and of course, Pokemon Go. John, you know what? I'm ready to talk about it. I've got my container right here.
Perfect. All right. So again, we're talking about containers, orchestration, and Kubernetes. Let's start off by talking about food.
Wait. What does food have to do with containers? Wait, I get it. Food in containers. By the way, these are some awesome cornbread that my wife made this past Sunday. Very delicious. So let's get started.
Great. I'll definitely have to have you send those my way. So it's not exactly containers in that sense, but there are definitely a lot of parallels that are going on here. I really wanted to talk about food mostly because this is just such a great example of something that a lot of people use in a product that they're at least familiar with. We have Every Plate, we have Home Chef, we have HelloFresh. These are all meal prep boxes that have all necessary ingredients to make a delicious meal straight from your kitchen. They get delivered to your door. You don't have to go to the grocery store. And it really cuts off all the excess stuff. For instance, when you go to the grocery store and you grab your meals, you'll have excess vegetables left over and all these other stuff that ends up, costing you more money potentially, as well as being leftovers in your fridge. Containers are very similar in that sense, where they just have all necessary components and your libraries, your executables, everything you need to run your application. So really, it makes it a lightweight, portable box, kind of like every plate, and HelloFresh has meals in a box as well.
All right, John. So I like that explanation. And by the way, as we're continuing along, if you find me munching on a couple of the cornbread, just ignore me. But why are people switching to containers?
So first of all, let me kind of show off this little graph that represents that point you just made. Here's the containerization timeline. The Docker containerization debuted in 2013. Up to 2017, about 20% of companies have deployed containers. And up to 2020, very recently, half of all companies have containers deployed. For me personally, having used containers and utilizing these very scalable and very convenient containers, I can say firsthand that they're using them because of all the benefits that come with them. They're very lightweight. They can help you save money, and they can help you deploy things much faster. So companies are really switching over to them for the convenience factor.
Now, I noticed on the screen it says 50% of companies have containers deployed. Does that include just testing out, playing around with containers to see if they're going to work for their application? Or are those real production environments?
These are definitely a mixture of that, but I'd say most companies, once they start really testing out their containers and they're seeing all the benefits of them, they just turn into production environments. So I would say a majority of theirs are actually their production environments.
So you're saying dev turns to production in a natural instance where I'm developing, I'm just going to promote this to production. Never
Exactly.
seen that happen before.
For sure.
All right. So everybody, don't forget to check out the link below. I'll include it in the description. What are containers? And John, let's talk about a little bit of container orchestration.
Definitely. So, going back to that HelloFresh example, great. You've got, a nice little box with all your ingredients in your kitchen. That's very convenient and nice. But how did it get there? And not only how did it get there, but how do you know it's in a good condition? You've got good food inside. It's not spoiled. The box didn't get damaged within, transit, things like that. That's kind of like container orchestration. All these tools help you to automate your deployment, help host all these containers on different nodes. They manage the scaling. And, I have that picture of a delivery driver in the bottom right, two good-looking guys that just deliver the HelloFresh to your door. But they're really the best delivery drivers ever. They go a little bit further. They check to make sure everything is running properly. And yeah, same in container orchestration. They'll check the health of your nodes, make sure everything is great. So you'll leave that great review, and you'll have a wonderful cluster running and healthy.
Sounds like I could. So do each of those guys come with each of your container deployment? Because that would be pretty cool.
That's the beauty of it. There's no human interaction there other than deployment. So
I do like the analogy of your food and making sure that everything's good. But also when I am using my food right here, all the ingredients come together. And so what's interesting is they all fit into this nice container, into these delicious little bite-sized muffins.
Perfect.
All right, John, I'm really curious because we're talking about containers, but I've got all these things deployed out in my environment, some containers, some nodes, some pods. What are some tools that are available for this container orchestration piece?
Perfect. I'm glad you asked that. So this is a very important part to really be familiar with if you're gonna learn about container orchestration, is what options do you have? What tools are out there? And you need to be familiar with them because they do have a lot of advantages and disadvantages to each one. We won't go too in depth with it, but here I've kind of included the little icons or logos, whatever you want to call them, for many of the different orchestration tools. The entire top row is Kubernetes. So if that doesn't tell you how important it is, I don't know what will. Up in the top left, you have the basic Kubernetes symbol. And then the other three on the top are actually the major cloud providers managed Kubernetes services. So you have Amazon EKS, you have Azure Kubernetes Service, and you have Google Kubernetes Engine. Again, those three are their managed Kubernetes services. And then at the bottom, you have other orchestration tools such as Docker Swarm. In the bottom left, you have OpenShift, and you have Rancher as well. Of course, there are many others out there, all with there are different kind of styles and architecture, but the one we're going to focus on today is actually going to be Kubernetes.
Now, all these have their plus, minuses, pros, cons, and benefits. You have to find out what works for you in your deployment. Obviously, I'm a little bit favored towards the left side of the top left, but we won't go there because there are some other clouds available, which is interesting that you have them on the same screen. But we won't do that. Before we move on, don't forget to stick around and watch John and I play the T-Rex game for bragging rights. Also, who's going to buy each other around whenever we get together.
Great.
So, John, how about we talk about Kubernetes and a little backstory on it?
Sure, definitely. Now, I want to talk about Kubernetes mostly because it's the most common container orchestration tool out there. So if you're going to start to learn, might as well start with the most common one. Now, this was developed and open sourced by Google back in 2014. So if you ever see a job requirement that says 10 plus years of Kubernetes experience, you know they don't know what they're talking about. So it's been out for about 7 years now. It's actually a Greek word. It actually stands for helmsman or pilot. So that's interesting. And there's also, you'll notice at the top, it says Kubernetes and in parentheses K8s. So the abbreviation K8s is derived by replacing the 8 letters of Kubernetes with the digit 8.
Well, wait a second. When I first heard this from you, I was a little, how does the K8, it doesn't say K8 is not pronouncing like Kubernetes. It's just abbreviation. And I thought I was lazy, but I mean, they just threw 8 in there and just made it a shortened.
Hey, Kubernetes can be a long-winded word. Sometimes it's nice to have it shorter, sweeter. Developers like to quickly slur through their sentences, so we'll just go with K8s. And when you're typing it, it's way easier as well.
Now, quick question. I see that you have, and this is just going to be funny. I'm sorry. You have K as capital, 8S. Is it lowercase or capital, or doesn't it matter?
Oh, I don't think it matters. It's just a title.
I just figured I'd be a little picky because abbreviation can't, all right. Anyway.
Hey, so don't need to be
on, John.
It's an abbreviation. Come on. It can be whatever it wants. Cool.
Well, wait. Oh, hold on. Oh my God. I can't believe I allowed you to put this slide in here. Wow. Does this it looks like an electrical engineering slide. John, you got to help me understand this because I'm not sure where to start.
See, that's the exact reaction I was hoping for, because to be honest, this has nothing to do with Kubernetes, has nothing to do with containers, orchestration, anything like that. It's just a really confusing slide. And here's the beauty of this slide. If you can really find any beauty here. But if you look around and start reading each of these little sections of it, you'll actually kind of start to understand what's going on, right? At the top middle, you'll see like production control, then you'll see like suppliers, and then little trucks. Towards the bottom, you'll see things like milling, welding, painting, and assembly. So we're starting to see that there's some kind of manufacturing happening here. Then up on the right, more trucks, and then customer A and B. So once we really start to kind of read what's going on here, we can really understand what's kind of happening. Now, I don't know what product this is. Obviously, it includes some kind of welding and painting. But the point is, like, immediately you might get that shock of, wow, there's some funky arrows and everything's all over the place. Like, what's going on here? When in reality, if you start to really read and break this down, it's not that difficult to really understand. So with that being said, you can really understand anything if you kind of just break it apart and really look into it.
All right. So John, that was a good explanation of the slide, and you helped me understand how the pieces come together from the production of making the product all the way to the customer, and then the product forecasting. And after a few minutes, you get a chance to digest it. So you really helped me understand, throughout all this Kubernetes or K8s, what does a typical Kubernetes cluster look like?
Perfect. So now that we've kind of looked at that really difficult one, like you just stated, let's look at a much more simpler one, which is the Kubernetes architecture here on this slide. There's a lot less going on here, so there's no need to be afraid when we're seeing all these, arrows and all these vocab words, especially if you're not super familiar with Kubernetes architecture or vocabulary. But really, you'll see on the left, you have a master node. I won't get into too much of what's going on here. That can be a deep dive for another time. On the right, you have all these different nodes, and they have all layers within them. They have their pods, and within each pod, you see the containers. And so I kind of just threw out here to the side, these are just important vocabularies, words just to know so you can be familiar with Kubernetes. And it will be much more easygoing in conversations. You'll know when that's actually being talked about. So the words I put are a cluster, that's the entire thing. Master node, here's the left, or this could be considered your delivery driver when it comes to HelloFresh. You have your node.
There you go.
Yeah, you have your node. This is what's housing, the box that it comes in, so to speak. You have your pod. These are kind of wrapping together each of the ingredients, and then, the container itself. Or you can think of the container as the whole box itself. Either one works in this example, but there's just layers, and you go deeper and deeper as you go into it.
I was going to ask you to break down each one and understand the container in the node, in the pod, and then in the node, but an excellent explanation of it. Simple, but yet very powerful. And before we move on to Pokemon Go, don't forget to hit that like, subscribe, some comments, anything else you want to see. And hang tight real quick. We're almost done here where John and I are going to play the T-Rex game for some bragging rights. All right, now on to, which I'm sure a lot of people are interested, how the heck does Pokemon Go fit into this whole conversation of Kubernetes?
So Pokemon Go has a special place in my own heart. I know, I'm young. I actually played Pokemon Go. So a lot of these statistics here are something I myself contributed to. A little about Pokemon Go. It was downloaded 750 plus million times. I'm sure that's, increased since I've even put this together. 5.4 billion miles were walked. So there was a lot of pounds that got shed off, a lot of sweat all over this game. I know I at least did 100 miles on this game myself. But what's important...
Was that driving miles or walking miles?
Oh, okay. It was a mixture of both. Sometimes you drive to... They have little gyms you have to drive to it.
How far have you driven to capture one?
I probably drove 10 miles to get to like a nearby gym or something. I wasn't too obsessive about it. It was more along the way, but I'm sure there's individuals who drove 100 miles to get to like some rare location, but I wasn't that obsessed.
Wait, I'm sorry to anybody, if you're actually still watching the show, please comment down below. I'm curious, how many miles have you drove to actually capture one? How many miles have you walked to actually capture one? I want to see the difference here. All right, John, go ahead. Keep going.
Sure. So I'll skip this next point and come back to it. But an account actually sold for $10,000 US. So imagine going out, capturing a bunch of Pokemon, turning around and selling it for 10 grand on the internet. So very, very profitable if you were good, I guess, or got the right Pokemon. And then back up to the point above, it received 50 times the anticipated traffic. And this in itself was the problem. When developers make applications, they're kind of taking ballpark guesses, and they take, a little bit of cushion and add it to their infrastructure so that in the rare case that their demand goes far beyond what they expected, they'll be okay. But it's very hard to anticipate 50 times the amount of traffic. So basically, they got together with Google. Google, was working on Kubernetes right around that time. It was fairly fresh and new. And they worked together and put Pokemon Go on Kubernetes, which basically allowed it to properly scale, properly handle all the traffic, got containerized and did its special Kubernetes magic, and it was no longer crashing. I know back when I was playing Pokemon Go, one of the biggest frustration points day 1 and 2 was servers are down. I can't even get into my application. Oh no, I can't go catch Pokemon. And so after utilizing Kubernetes to meet demand, that really solved the issue, and it became the amazing game it is today that people still play. So
I find that very interesting in how we got Pokemon Go into this whole conversation. I have to tell you, when it first came out, I mean, I never downloaded it. My kids did. They downloaded it on my phone. Trust me, it wasn't me. And they were trying to capture all the time. And I was afraid. I would see people in fields. And I was trying to figure out, like, why are these people there? and I was always afraid that somebody was going to cross traffic trying to drive around and capture one. And it'd be like, all right, we have to be careful because people are, they're always looking down at their phones anyway, but now they're really looking down at their phones trying to capture something. Really cool explanation of Pokemon Go. I really find it interesting how Kubernetes came into play here. So, John, how about we dive into Spot's product called Ocean and how it can help, and where does it come into play with Kubernetes?
Absolutely. So moving back on to Kubernetes, and this can really take place for many container orchestration tools. But Ocean by Spot, it's a serverless compute service, lets you run containers without provisioning or managing your servers. Really, it's hey, you've got a EKS or a Azure managed Kubernetes service. Ocean will integrate with that to help with cost optimization. It will do continuous right sizing. And again, it's seamless integration with just about any container orchestration tool across all three major cloud providers. Now, to put that in a little bit simpler terms, let me kind of show you a little image of what it's actually doing. So it's a fully managed data plane inside your secured cloud. And it does a lot of cool stuff, such as like bin packing to allow you to kind of play Tetris with the different instance sizes. Regular Kubernetes clusters, they're provisioning new nodes, they're getting your infrastructure up and running so that it can support your demand. But what Ocean does is it adds another optimization component, which allows it to, hey, you're not using this many cores of CPU, it'll reduce that, or it'll provision a larger quantity of nodes in a smaller size if that is more cost effective with your cloud provider. So essentially, it turns a generic Kubernetes cluster that's just trying to scale to a Kubernetes cluster that's trying to scale, but it's also trying to save you as much money as possible.
So, John, when you say it's trying to save you as much money as possible, in my mind, it's trying to use as many reserve or spot instances. So it'll go to your reserves. It'll say, all right, you don't need any more reserves. Let's try to utilize spot. And in the last case, let's do some on-demand instances, but we'll revert back when they're free and available, correct?
Exactly. So the big premise of Spot by NetApp and our products are to utilize Spot instances wherever they're applicable. Now, if you have commitments such as reserved instances, they're going to utilize those as well. But really, it's trying to avoid using on-demand instances. And in this case, it's really seeking out all those 90% discount Spot instances to integrate those into your clusters where possible and save you as much money as allowed, really.
What we like to call marketplace gold. Those spot instances that are out there, they're really cheap. We'll run on them. It's very interesting how Spot has become an awesome product for your Kubernetes environment. If you want to find out more information around Spot Ocean, don't forget to take a look up here. I did a really cool touchscreen demo of how all the pieces come to play. Now, before we move on, John, would you like to wrap things up and provide us a summary on Kubernetes and Spot by Ocean?
Sure. So first of all, we talked about containers. That's just packing all of your executables, all of your libraries, everything you need into a small little HelloFresh box, right? You have your orchestration. That's your delivery driver that's making sure it gets to your door. Kubernetes is one version of that orchestration tool. That's the most common. Please be familiar with it if you're interested. And then we have Ocean, which just integrates Spot instances into your clusters for cost optimization.
All right, pretty cool here. Okay, now time for the main event. Okay, I'm sorry, I get too excited for this T-Rex game. John, I'm going to share my screen. I'm going to go first so you know what you have to beat. Let me put down my container and my snacks for later. All right, let's get the screen up here. I'll share this in. Okay, let's play the infamous bingo. Can you see my screen?
Yep, let's do it.
All right.
Glad I made you go first.
Yeah,
I gotta know what I gotta beat.
I'm telling you, I might be pretty good. On a count of three. 3, 2, 1. I make noise for it.
And you had a double jump right at the start.
I know. You know how it picks up my name? I think it's recording how well I'm doing, and it's like, all right, I'm going to give you some Harder one.
swapping the difficulty on you. See,
Yeah,
I played this
I'm gonna have
one
to do
time.
this like incognito mode or something.
I hope it's doing that because I have not played it much, so maybe mine will be easier.
So it doesn't have my like highest score, but you notice it's getting faster. Wow.
I'll be honest, I'm already getting nervous.
Oh,
ooh, there we go.
508, 508, a little bit less than my max. All right, John, time to share yours, and you are up.
All right, let's see how this goes.
Click on the screen and then press. You know what? Do it before you do that.
Ready?
Can you enlarge the screen?
Yeah, is it not fully enlarged?
Do a Control plus plus. I want to see the browser is not because you have your 49-inch monitor. I'm not seeing it.
Oh, is it all weird?
No, it's just smaller. I'm seeing all 49 inches of your screen here.
Oh, huh.
Do Command plus plus.
Did that work?
A little more. Perfect, right there, man.
There we go.
Nope. Oh, you can't see it. And you see right there.
Okay.
That's awesome.
I'm not gonna touch it now.
All this into the recording just because it's fun. Okay, once you click on it, you hit the space bar to start and just hit your up arrow.
All right, here we go. Wait, is it space bar or up arrow to jump? I think it's just space bar.
Space is just a start.
Nope, I'm using space bar to jump.
Oh, mine was I was using the up arrow. Hey, whatever.
Hey, I had a double jump at the start too, so I feel like this is...
Oh, it knows us. I'd say move your mouse, but I don't want you to be interrupted. Oh, look at him, look at him, look at it. Oh, man. Oh.
See, I can blame it on that. Oh, no!
Oh, yes!
Only 235, not even half your score. Oh, man. It was the mouse movement.
I continue the reign here with
It was the mouse movement.
Oh, sorry, no do-overs on the game over.
All right. Next time we meet, rounds are on me, I guess.
Yeah. I will give you a rematch here in the future on our next recording that we do, but I'm going to keep my bragging rights to it. It was less than my other one, but not bad. All right, John, thank you so much for joining me and sharing what is Kubernetes, what is containers, what is this orchestration, and Pokemon Go.
Yep, super happy to be here. I really appreciate it, John. Thank you.
All right, John, have yourself a good one.
Take care.